Okay, this is lesson 38 for 8th grade, and today we're talking about properties of equality to solve equations. Now, we've been doing this for a while, but we're going to hit it again because this is definitely algebra, some simple algebraic things that we need to make sure we have on lockdown. Alright, so we want to review our solving strategies today. And we're going to take our solving strategies to a higher level so we can think more algebraically. So, review, yes, but obviously we're always going to take these things to the next level. So, we've practiced solving equations by inspection using logical reasoning. In this lesson we will use inverse operations to solve equations. Inverse operations undo each other. Now, I've already talked about the inverse operations. I've kind of introduced them before the book wanted us to see them. But that's because once we got to this point, I wanted us to at least have seen them already. So addition and subtraction, they are inverse operations. So if we have n plus 5, we could always subtract a 5 to get n, or solve for n. Because adding a 5 and subtracting a 5, they undo each other, right? Multiplication and division are inverse operations. N times 5. Okay? If we wanted to solve for n, we would divide by 5, because 5 divided by 5 is 1, and n times 1 is just n. And that's why we can do these things. Alright, inverse operations help us solve for that variable. Another one that we've seen this year, Pythagorean theorem. If we have something like x squared equals 49, we know that we can take the square root. Okay? So squaring and square roots are the same thing. You can get x equals, and now we should know that we can get a positive or a negative 7, because 7 times 7 is 49, but negative 7 times negative 7 is also 49. Okay? So squaring and square roots are inverse operations. We use this to solve for variables. Alright? Now if we take a look at it with this balance model, it might help us. We don't know what x is, but we do have a total weight, and these things are in balance right now. The only problem is we have x plus 5 over here, and that's equal to 7 plus 1 plus 4. So we actually have 12 over here, x plus 5 over here. Okay? So the equation, x plus 5 equals 12. And the reason this is true is because our equation is in balance right here. This side is equal to this side. So here's what we can do mathematically. We can take a 5 away from each side. And the reason we have to take it away from each side is so that we're still balanced after we do that. So when we do one thing to one side of the equation, we have to do it to the other side. Alright? And we've talked about this before. But this should help us visualize and help it make sense. Okay? So we are isolating the variable, and that means that the variable, like x here, is alone on one side of the equation sign. And we should find out that x equals 7. Maybe we were in pounds here. So if we go back, 7 pounds plus 5 pounds is 12, and that's what we have here, 12 pounds on this side. Okay? Alright? So just remember that when we do one thing to one side of the equation, we have to do it to the other side to keep things equal and balanced. Alright, so here are the two main things when we isolate a variable. We choose the operation that will isolate the variable, and then we perform that operation on both sides of the equal sign to keep the equation balanced. So here are some operations that we have here. It says performing the same operation on both sides of an equation preserves the equality of it. So we just saw that with the balance problem. If we took 5 away on one side and took 5 away on the other side, everything stayed balanced. So these are properties of equality that we can use. So if we have an equation a equals b, and we decide to add a number to this side and the same number to this side, it doesn't matter, we're still going to have this equality on each side. So if we add c to a plus c, we have to add c to b to keep everything balanced. Alright? We could also subtract. A minus C is the same thing as B minus C, as long as these two things are equal. Multiplication. I can multiply A times C and B times C, and we'd still have the same thing. And we could always divide by C. A divided by C will be the same thing as B divided by C, as long as A and B are equal, which that's what all of these say. This says here, as long as C is not 0, and the only reason they put that is because you cannot divide by 0, so they just need to put that out there. So let's just take a look at this here. After spending $2.30, Robert had $5.70. How much money did he have before he spent $2.30? Now we'll be able to set these equations up, or at least we should be able to, if not now, very soon. But they set this one up for us. So we want to get x by itself, we want to isolate it. Now we got to figure out what's happening to this x. Well, we're taking away $2.30, so we're going to do the inverse of that. And we're going to keep both sides of the equation balanced. So whatever I do over here, I have to do over here. Alright? You're left with x equals, and the reason this works is because if we add $2.30 to some, so we're subtracting $2.30, if we look at just these two, it's like adding positive 230 plus a negative 230 is 0. So x plus 0 is just x, and that's why you're left with just x on this side. But we also have to add 230 over here since we get it over here. So we get 0, 0, and then 8. So x should be $8. Okay? And we should know that that's our answer. X is by itself. We've got one number that it's equal to. We solved it. Okay, next one. If a 12-month subscription to a magazine costs $8.40, what is the average cost per month? Okay, so that means 12 times M equals $8.40. We probably know that we're just going to end up dividing $8.40 into 12 pieces anyway. But yes, 12 times a monthly amount would give us the average cost. And what we end up doing is, since we are multiplying, we do the inverse of multiplying, which is dividing. We have to do that for both sides. Okay? And I like to write division kind of in the fraction way. This means 12 divided by 12. Well, 12 divided by 12 is 1. And 1 times m, 1 times anything is itself. So we're just going to be left with m here, okay? Or you can think about it as those things are canceling each other out. $8.40 divided by 12. Well, I'll just do that up here. You can use a calculator if you want. This will be, I don't know, 6. Doesn't go in there. Let's try 6, 12. Subtract, we get 120, yeah, we drop that down. So 12 goes in there, what, 10 times? Oh wait, we want to do this. We don't need to drop that down. We get 12 there, we get 1. 1 times 12 is 0. 0. So 61 cents. M would be average price would be 61 cents per month. Alright? And I think I got one more. So this should kind of be a review, but we wanted to hit the inverses again, because I did introduce it fairly early. Alright, now this one's a little different. I'll show you a shortcut you can take with this, but let's think about what it means. This equation says 2/3 times W equals 3/4. So what is the inverse of multiplying? Well, that's dividing. So if we do 2/3 divided by 2/3, well, here, let's think about this here. We are going to divide by 2/3 because we are multiplying by 2/3. So 2/3 times W, we want to do the inverse of multiply, which is divide. Well, 2/3 divided by 2/3 is just going to be 1. You're going to be left with just W, right? Because whenever we divide by the same thing, we just get 1. Like 2 divided by 2 is 1. 3 divided by 3 is 1. 100 divided by 100 is 1. So 2/3 divided by 2/3 is 1 times W, which is just W. But we also have W now equal to 3/4 divided by 2/3. So we had to do that on both sides. But our fraction rules say that we're going to turn this into multiplication after we flip this one around. Right? So this is actually 3 times 3, which is 9, all over 4 times 2, which is 8. And this is actually, so we need to say 9/8 or 1 and 1/8. And that would be our answer, 9/8 or 1 1/8. And I'll show you a shortcut you could use. Yes, we did divide by 2/3. But what we can do, and if you remember this, you can just multiply by the reciprocal. So if I multiply this by 3 over 2, notice how these two are going to cancel out and those two are going to cancel out. And if we multiply right away by 3 over 2, we still get that 9 over 8 or 1 1/8. So it's faster, and technically you're still doing the same thing, but it's a shorter way of doing it. Multiplying by the reciprocal is the same thing as dividing by the original fraction. So it still works out. And I like to do that, it saves time. Alright, we have one more thing to do here, and then we'll be done. Property of equality. It is customary to express a solution with a variable on the left side of the equation, which you will see me do often. So if we end up getting something where we have the letter on the right side, and we'll essentially move it to the left side. And that's something we can do because if A equals B, then B equals A. It doesn't matter which order we state that in.
Charlie Grohl to the office, please. Charlie Grohl. Charlie Grohl, please come to the office.
Okay. Now I won't be a huge stickler on that. If you put the letter on the right side, that's okay. I just want to make sure that we can get that solved anyway. But it is customary to have the letter on the left side. So let's do this quick. This says x minus 2.3 or 1.5 equals x minus 2.3. What's happening to our variable? We're subtracting 2.3 from it. So we're going to do the inverse. We're going to add 2.3. We're going to add 2.3 on this side. These will cancel with each other. We're going to be left with x. And then if we add, we get 5 plus 3 is 8. And then 3, 1 plus 2. So x equals 3.2. What we're saying here is that we can state this either way. I'm going to say x equals...
Dane Jensen to the office, please. Dane Jensen.
X equals 3.8 as opposed to 3.8 equals x. So that was today's lesson, and we'll talk more about it tomorrow.